Hello, my name is William Roya with Challenge 2016, and I'm here to talk to you about functions. So, as you can see here, a function is pretty much right here. This is our function. F to x to y to z to some variable to some input, where anything within the parentheses is our input. Then anything what that's equal to, that is when we want to get out of the function. So then x squared, x to the cube, x plus 3, or x2x plus 2, 2x plus 3 divided by 2. All those are functions. There are different kinds of functions and multiple variations of functions. So if we were to have something like f of x is equal to let's say x squared, back here to our example, we go ahead and input 1. If we were to input 1, then over here on the outside we would output 1 as well. So then we would have f of 1 is equal to 1 squared. So then we will have f of 1 is equal to 1, because we know 1 times 1 is 1. So next, I'll talk to you about what it means for a function to be 1-to-1. When a function is 1-to-1, that means for every time you have an x, you would get some y value. So let's say we graph a function here. So we're going to graph a function like f of x is equal to x plus 3. If we were to go ahead and graph this function, we would know that up here we would have some point being 3, and then we have another point up here being 4, 1, 4, and then so on and so on and so on, and up to infinity to infinity. We would have infinite number of values here, infinite number of values here, and to keep going on and even go down here through negative infinity. So we're going to go ahead and graph this. You'll notice that for every instance where there's a y value, anytime there's a y value, there's also another x value as well. So right here, you notice that every time there's an x, there's a y. But notice there's only one x and not two x's, three x's. There's only one x to one y. So no matter what happens, if a function is supposed to be 1 to 1, there's only one x value for every y value. So let's give an example where a function is not 1-to-1. So let's say we have a function where we have f of x is equal to the sine of x. This means that, well, this would be good about the graph right here, is that I'm going to show you that pretty much the graph is the same. This right here is a basic sine graph. Pretty much right here is one basic sine graph. So you would see here that we have a basic graph here, and then we have multiple points. But also I want you to notice that for certain x values, there can be multiple y values. So pretty much this function right here, sine of x, is not 1 to 1. Because within its domain and within its range, there is multiple instances where multiple y values can have multiple x values. So like this point right here, this y value right here will also have this y value up here. This x value right here and this x value right here will have the same y's connecting to each x. So then, or we have the same x connected to that same y. So then this means this function cannot be 1-to-1. And an easier way of doing this would be if you were to go ahead and do the horizontal line test. So we're going to have a function here, and let's say we do the function f of x is equal to x squared. We would get a simple parabola. And so right here we would see our functions right here where f of x is equal to x squared. And we were to go ahead and, the horizontal line test is where you go ahead and draw a horizontal line through the graph. And anytime the line touches the graph twice, that means that this function is not 1-to-1. So this right here is not 1-to-1. So then this function is not 1-to-1. This function can't be 1-to-1 because there's a y value here that is equal to this y value, but there is multiple x values to that individual y. So then that means that this function cannot be 1-to-1. So now let's talk about inverse functions. Inverse function is pretty much the same way of saying that, the same thing as that, this is the symbol, this is what it means. This is the symbol that you'll see when you see an inverse function. You'll more likely see an f with a minus 1 above it. So then we would have write that, you know, f of x is equal to, if f of x is equal to x, then that means, and then we have to draw the inverse function. We have the f of the negative, or we have the inverse f of x is the same thing as saying 1 over f of x. So since it's the same thing as 1 over f of x, then that means that if you're to go ahead and let's make the function, I don't know, f of x is equal to 2x plus 3. If we're to go ahead and do that, but we want to know the inverse of this function, we would first have to go ahead and set it equal to y. So we have y is equal to 2x plus 3. We would subtract 3 from both sides because we want to get x alone. And then we end up with 2x. Then we divide both sides by 2, or we get y minus 3 is over 2. So you see here, where we have y minus 3 is above 2, and then we know that this is equal to x. But we want to be sure that's true. So right here, let's input a value for x here, call it 4. So we have f of 4 is equal to 2 times 4 plus 3. So then we have f of 4 is equal to 8 plus 3, which means that f of 4 is equal to 11. So now we know that f of 4 is equal to 11. But remember that this is y is equal to x, not x is equal to y. So then if that's the case, that y is equal to 11, we can input it back to our inverse function, where we have inverse is equal to 11, or the inverse function of 11. So then we have that 11 minus 3 over 2. So then the inverse function is then equal to 8 over 2. So then the inverse would then end up being equal to 4. So that is our inverse. So that is our inverse function. But now let's go ahead and let's graph an inverse function. So for the graph an inverse function, let's say we have the function, or let's say we have a function where, let's go back to our example of f of x is equal to x, you know, the basic line graph. What we would do then is that in order to figure out the inverse, we would have to flip the domain and range. So pretty much we know, pretty much here, it's all x values and all the domain will be all x values and all real x values and all real y values. So this may not work out the same. Well, it will work out the same way, because if you flip the domain range, it'll be exactly the same, because it's also the same as that it's all y values. But let's use something different. Let's say instead of using f of x, we would use x squared. So instead, we would get a graph. We would get a graph that's like this. So we have a graph like this. If we were to take the inverse of this graph just by looking at it, what you would do is that, you know, our domain would be all positive. All positive x values. Well, yeah, it would be all x positive, all negative to positive x values. But our range would be 0 to all positive y values. But if you do that, then the thing is, our range would then be flipped with our domain. You know, that's another way of doing it. So pretty much then our inverse function is equal to our inverse function would be, if you were to go ahead and do the opposite of this, which then if you would do the opposite, we would have that, you know, the square root of y is equal to x. So then what we would end up with is that we would have this being plus or minus y, and then our graph would look something around the lines of this. If we were to do the inverse of this function, it would look somewhere around, it would almost be like this. Completely flipped upside down. Our inverse of the function would be instance where the graph is almost flipped completely upside down, so that our domain is now not all positive. It would be from 0 to all. It would be from negative to all 0. It would be negative infinity to 0 for domain, and our range would be all negative values to positive values. So that is the quick synopsis on functions. And again, I'd like to say my name is William Roy, and I'm in Math 1000.